Today we're talking about reflections. So our first transformation was translations, where we were moving left and right, up and down. Now we're going to be talking about reflections. Top box of your notes. A reflection is a transformation that uses a line like a mirror to reflect a figure. A reflection is a transformation that uses a line like a mirror to reflect the figure. The mirror line is called the line of reflection. And just like a translation, a reflection is a rigid motion, which means that we do not change the size or the shape of the figure when we reflect it. We don't change the angle measures. The lengths of the segments all remain the same. We'll just be in a different location, different orientation. I believe you did this last year as well. Okay. So you have a figure on your drawing. It's a triangle, ABC. And triangle ABC is going to be reflected across line R. Reflection line R. When it gets reflected, it's a mirror image, left and right. And if the line happens to contain one of the points of the image, its reflected point is itself. So A is A prime, because A was on that line of reflection. So you would just write A prime right beside it. And if in this case, the other two parts, the pre-image B and B prime, are equidistant from the line of reflection. So the same number of steps across. Likewise, C and C prime are equal distances from that line of reflection. So when we're looking at horizontal and vertical reflections across the X and Y axis, or a line Y equals something or a line X equals something, then we are dealing with counting the spaces to figure out where that new point or figure is going to be. So let's look at this first example. Second box of your notes. Find the image of P, which has an ordered pair of 3, 4, reflected across the line X equals -1. So your first step is always to write the pre-image, to plot the pre-image. So go ahead and plot P at 3, 4. Label it P. Now graph the line that it's being reflected across. So we're asking you to reflect it across a line X equals -1. X equals -1. Is it a vertical or a horizontal line? Vertical. We go to the place where X equals -1, and we draw a dashed line. Make sure you dash it because you don't have colored markers like I do. So dash that line so you don't confuse it with the y-axis. Now P needs to be reflected across that line. So when it's reflected, it'll be equal distance from that line. So how many steps is it? 4. So we need to go 4 more steps to get to our P prime. Okay? Everybody good with that one? Okay. Next example says, reflect triangle ABC across the x-axis. Which one's the x-axis? The horizontal axis. So if it helps to dash that axis, feel free to do so. Which point do you want to reflect first? C, okay? C is at the point 0 over 1 up, so 0, 1. Where's it going to be if we reflect it across the x-axis? 0, negative 1. Good. So we bring it down from 0, 1 to 0, negative 1. Happens with B. Where's B at? It's at 4, 4 right now, so it will be at 4, negative 4 when it's reflected. Make sure you label it B prime. Okay. Third point A. Where is it at? It's at negative 3, 5 right now. Where will A prime be? Negative 3, negative 5. Good. Connect the points. And they have been reflected across the x-axis. Everyone okay with this one? Okay. Next example. What is the image of triangle ABC reflected across the y-axis? So which one's the y-axis? Okay, the one that it's currently crossing, right? The vertical axis is our y-axis. Good. C is going to stay the same, isn't it? So we can label C prime immediately. Just call it C prime because it's on the line of reflection. Okay. So B is currently at 4, 4. Where's it going? Negative 4, 4. B prime is at negative 4, 4. A is currently at negative 3, 5. Where will it go? Positive 3, 5. Good. Now that you have your 3 points, connect them. Draw the segments. Everybody good? Not yet? Give me a few moments. Okay. All right. Next example. So what is the image of P, which is 3, 4, reflected across the line y equals negative x? Maybe negative 3, negative 4. Okay, we'll check. Good question. Good suggestion. So y equals negative x. First of all, this is y equals negative x plus 0. Our slope is negative 1. It crosses through the origin. Down 1 over 1, down 1 over 1, down 1 over 1. So that's how we graph that line of reflection. So we think that maybe if we're trying to find the image of P, and it's 3, 4, that maybe it will be negative 3, negative 4. So let's check. If we go 3 back and 4 down, does that look like a mirror image across that line of reflection? Not quite. So maybe it's negative 4, negative 3. Let's try that. If we go 4 back, 3 down, and look at that P prime, does that look like it is a mirror image of our line across the line. Yeah. And depending on how the projector projects this will have an impact on whether it looks right or not, whether it stretches my image out and so on. Okay, so we'll talk about a rule here in just a moment. Okay, but I believe that you're closer to it with switching the x and y coordinate and changing the sign of each. Yes, sir. And how would you find it? Mm-hmm. Okay. All right, so Braxton suggested counting down from P to this line. 1, 2, 3, 4, 5, 6, 7. 7 spots here. And then 7 this way. 1, 2, 3, 4, 5, 6, 7. Looks right, doesn't it? That still works as well. Okay. That looks a lot easier. Okay. You have to draw the line sometimes. It'll tell you what your line of reflection is going to be. Okay. Next example. What is the image of triangle ABC reflected across the line y equals x? So here's my pre-image. A is still negative 3, 4. B is still 4, 4. And C is 0, 1. The line y equals x. Alex, put it away, please. The line y equals x is a line y equals 1x plus 0. Goes through the origin, rises 1, runs 1, rise 1, runs 1. When x is 0, y is 0. X is 1, y is 1. X is 2, y is 2. Okay? Which would be the easiest point to reflect? B, because it doesn't move, does it? So we'll have a B prime that will be at that same spot. What's the next easiest one to reflect? C, because it's close to the line, right? So C is currently at 0, 1. Where do you think it will be when we reflect it across the line y equals x? One, 0 looks good to me. We'll call that C prime. That's at 1, 0. So what do you think A prime will be? 4, negative 3. Makes sense. Let's try it. And those of you with good spatial sense will be able to decide if it looks right when we connect these points. Sorry, it was 5, negative 3. Thank you. This was negative 3, 5. Does not look right because I did not graph it properly. 5, negative 3. There's my new point, C prime. So we switched our x and our y coordinates. Okay? So you figured out those rules already. Coordinate rules of reflection say that if AB is reflected in the x-axis, then its image is A negative B. If the point AB is reflected across the y-axis, then its image is negative AB. Switch the x, make it the x coordinate negative, or change the sign. If the point AB is reflected in the line y equals x, then we have to switch the x and y coordinate around. And finally, if the point AB is reflected across the line y equals negative x, then its image is going to have the x and y coordinates switched and the opposite sign. Switch and negate. Okay. Kind of. This is like the contrapositive, isn't it? Switched and negated. Whereas this one was converse, just switched. This one's similar to neither because we didn't negate just one or the other. Okay? But converse and contrapositive, I would agree, similarities there. All right, next one. A glide reflection is a transformation that involves a translation followed by a reflection. So we're doing two transformations, performing two transformations, one after the other. We start with a translation, and then we reflect. The line of reflection has to be parallel to the direction of the translation in order to be a glide reflection. A glide reflection will be a rigid transformation because a translation is rigid, a reflection is rigid. We're not changing the size, shape, or the angle measures. All right, so graph triangle ABC with vertices A is the point 3, 2. So plot 3, 2, label it A. B is 6, 3. So 6 over 3 up, label it B. And C is 7, 1. So plot 7, 1 and label that C. We're going to perform a glide reflection here. So I want you to translate it. What does it mean when we say translate the ordered pair xy to x minus 12y? Move it 12 to the left. So take every point on triangle ABC and move it 12 to the left. Take your whole triangle, each of those points. So you're going to take each of these points and move them 12 to the left. Label them A prime, B prime, and C prime. All right, so we've got our translation. Now we want to reflect it. So because we went horizontally when we translated, we're okay to reflect it across the x-axis. That's the horizontal axis. So reflect A across the x-axis, reflect B across the x-axis, or B prime, sorry. Reflect your translated triangle. So A prime and B prime and C prime are going to be reflected. Label those A double prime, B double prime, and C double prime. So once you've translated your triangle to the left 12 spaces, Yep, then reflected across the x-axis. So we translated 12 units over, and then we reflect it down. So C prime was at negative 5, 1. Now C double prime will be at negative 5, negative 1. A prime was at negative 9, 2. It'll be at negative 9, negative 2 for a reflection, A double prime. And with B prime at negative 6, 3, B double prime will be at negative 6, negative 3. Did everyone's image end up where mine did? Okay, good. All right, last example. In our last example, we want to decide how many lines of symmetry the hexagons have. So we have a widened hexagon. We have a regular hexagon. And then we have one that is bowed out on one end only. So all of these are convex. Okay. So which way do you think we can cut this to be reflected perfectly? Up and down, I would agree. Up and down makes sense. If I can draw a straight line right down the middle. Okay. Down the middle, horizontally. Corner to corner is not going to work. Okay. Because if I go corner to corner, when this comes up, it's going up here. Right? When we reflect it, it's going to be like this. Okay? So there's only two. And you can try folding your paper and seeing if it will, if you can see it through the light, you'll be able to see. Okay? All right, second example of this one. Okay? Everybody agree with 6 on this one? No? All right, so proof is in the pudding. Let's try it. Which way do you want to start? Up and down. Side to side. Okay, so vertically through the diagonals. And then what about, yes, what about through here? And that would be 6. 6 if I drew them correctly. Okay? Last example, what do you think? 1. Which way? Horizontally. I would agree. Okay? All right.